Question 1. From the perspective of HVACR system design and sizing, Nguyen is tasked with selecting a cooling unit for a new commercial office. The calculated sensible cooling load is 40,000 B2, but latent load is unusually high due to occupancy in kitchen facilities, totaling 20,000 B2. The building is located in a hot, humid climate. Which of the following best describes the critical consideration Nguyen prioritize when choosing the system? A. Select a unit with oversized sensible capacity to rapidly cool the space, ignoring latent load. B. Choose equipment capable of handling both sensible and latent loads adequately to maintain comfort and prevent moisture issues. C. Prioritize latent capacity only since moisture removal is the primary concern in hot, humid climates. D. Use a unit with minimal latent capacity to reduce energy consumption, as latent loads are typically less important. Answer. Correct answer. B. Explanation. When sizing HVAC equipment, especially in hot, humid climates, it is critical to address both sensible and latent loads to maintain indoor comfort and prevent mold or moisture damage. Oversizing sensible capacity A leads to short cycling and poor dehumidification, while ignoring latent load can cause humidity buildup. Prioritizing latent only C or minimizing latent D is ineffective, as a balanced approach ensures moisture control and temperature comfort. ASHRAE 62.1 and HVACR design principles emphasize that equipment selection must meet total load conditions, not just sensible. Proper latent load handling is essential for air quality and occupant health. Question 2. Considering the evidence from advanced diagnostics is Patel encounters a refrigeration system where the compressor motor frequently overheats despite normal voltage readings. She notes the motor windings have slightly increased resistance. What should be her most probable diagnosis and next step? A. The compressor is mechanically faulty and needs immediate replacement. B. There may be a developing winding short or deterioration. Test insulation resistance and consider motor rewind or replacement. C. The voltage readings indicate electrical supply issue. Recommend checking the power source. D. The problem lies in the refrigerant charge, so adjust refrigerant levels to correct overheating. Answer. Correct answer. B. Explanation. An increase in motor winding resistance combined with overheating suggests insulation breakdown or winding deterioration, a common precursor to motor failure. Simply replacing the compressor A may be premature. Voltage readings normal. C. Imply the supply is likely stable, and refrigerant charge D usually affects load, not motor winding resistance. According to E and NEMA standards for diagnostics, testing insulation resistance with a megameter and evaluating winding condition is critical to prevent catastrophic failure and extend motor life. Question 3. In light of recent developments in refrigerant regulations, Mr. Jackson is evaluating refrigerant options for a retrofit project in a medium-sized commercial chiller. The existing R22 system has leaks and poor efficiency. Considering environmental impact and compliance with EPA SNAP rules, which refrigerant choice aligns best with current regulations and operational efficiency? It replaced with R400 TINA, which is approved under SNAP and offers better efficiency but requires system component changes. B. Use R22A, an unapproved substitute that closely mimics R22 properties but is not EPA compliant. C. Convert to a hydrocarbon refrigerant despite flammability concerns. D. Continue using R22 with reclaimed refrigerant to avoid system changes. Answer. Correct answer. A. Explanation. EPA SNAP program prohibits most R22 use in new equipment and limits servicing with it. R400 TINA is an approved, non-ozone depleting alternative with better energy efficiency but requires system retrofit. G. Compressor expansion device. R22A. B. Is not EPA approved and risks penalties. Hydrocarbons C. Have flammability risks and are restricted in many commercial settings. Using reclaimed R22. D. Delays compliance and may not address efficiency or environmental goals. Thus, transitioning to SNAP-approved refrigerants like R400 TINA balances regulatory compliance and performance, aligning with EPA Section 608 regulations. Question 4. When evaluating the merits of smart HVACR and IT integration, Lewis manages a large building automation system. She notices significant data from sensors is delayed or inconsistent. What is the most likely technical reason and the best action to resolve this issue? A. Sensor calibration drift. Schedule manual recalibration and replace sensors as needed. B. Network bandwidth limitations causing data packet loss. Upgrade communication infrastructure or use edge computing. C. Software bugs in BAS causing data delays. Reinstall BAS software immediately. D. Power supply instability to sensors. Install uninterruptible power supplies ups on all sensors. Answer. Correct answer. B. Explanation. IT and BAS rely on real-time, reliable data transmission. Network bandwidth limitations and latency often cause delayed or inconsistent sensor data. Upgrading network infrastructure or employing edge computing to process data locally reduces latency and improves system responsiveness, while sensor calibration, software bugs, C, or power instability, D, may cause problems. Network issues, predominant cause of delayed sensor data in smart systems. This aligns with ISA 101 standards on BAS performance and industry best practices for IT-enabled facilities. Question 5. Given the circumstances where ISTA is preparing an HVAC preventative maintenance plan for a hospital HVAC system, which of the following best represents a critical element to ensure patient safety and regulatory compliance? A. Focus primarily on filter replacements quarterly since air cleanliness is the sole concern. B. Include detailed core cleaning, air balance verification, and ventilation rate checks per ASHRAE 170 standards regularly. C. Conduct only annual maintenance to minimize service disruption. D. Limit maintenance to mechanical components. Air quality is managed by separate systems. Answer. Correct answer. B. Explanation. Hospital HVAC systems require strict air quality control per ASHRAE 170, which mandates proper ventilation rates, filtration, humidity control, and regular core cleaning to prevent infection risks. Quarterly filter changes alone are insufficient. Annual maintenance, C, is too infrequent, risking system failure and non-compliance with Joint Commission and CDC guidelines. Ignoring air quality, D, jeopardizes patient safety. A comprehensive, frequent preventive maintenance program aligned with regulatory standards protects patients and ensures continuous system performance. Question 6. The core principles of thermodynamics apply to HVAC system performance. Mr. Fernandez is analyzing a refrigeration cycle where the compressor discharge temperature is significantly above typical values despite stable pressures. What underlying thermodynamic factor is most likely causing this? A. High superheat at compressor inlet increasing work and discharge temperature. B. Low condenser pressure causing refrigerant flooding. C. Expansion valve stuck open causing excessive refrigerant flow. D. Insufficient evaporator load causing compressor slagging. Answer. Correct answer A. Explanation. High superheat means the vapor entering the compressor is a higher temperature and enthalpy, increasing compressor workload and discharge temperature. This is a fundamental thermodynamic consequence as the compressor must compress hotter vapor, raising temperature further. First law of thermodynamics. Low condenser pressure B would reduce discharge temperature, not raise it. Expansion valve stuck open C would cause flooding, not discharge temp. Insufficient evaporator load D affects suction pressure but not necessarily discharge temperature. Understanding vapor compression thermodynamics is key here. Question 7. The relationship between duct design and airflow efficiency is critical for system performance. Mr. Lopez is reviewing a duct system with high static pressure losses and insufficient airflow in perimeter zones. What conceptual error in duct design is most likely causing this problem? Oversized ductwork causing low air velocity and noise. B. Excessive duct length with numerous sharp bends increasing static pressure drop. C. Using flexible ducts instead of rigid ducts regardless of layout. D. Oversized diffusers causing uneven airflow distribution. Answer. Correct answer. B. Explanation. Static pressure loss increases with duct length and number of sharp bends due to friction and turbulence, restricting airflow. This concept is central in duct design per SMACNA guidelines. Oversized ducts typically reduce static pressure but may cause noise, not low airflow. Flexible ducts C can contribute to losses but are acceptable if installed properly. Oversized diffusers D do not cause static pressure losses but may impact airflow distribution. Correct duct layout reduces pressure drops, optimizing airflow to all zones. Question 8. While examining a service operations challenge, Garcia manages a dispatch system where field technicians report frequent delays due to unclear job priority and incomplete work orders. What is the best strategy to enhance service operations and technician productivity? A. Increase the number of technicians to reduce workload per person. B. Implement a centralized scheduling system with clear job priority criteria and real-time communication. C. Allow technicians to self-assign jobs to improve flexibility. D. Use paper-based work orders to ensure physical record keeping. Answer. Correct answer. B. Explanation. A centralized dispatch with clear priorities and real-time updates improves resource allocation and reduces downtime, enhancing productivity. Merely adding technicians may not address root causes. Self-assignment. C. Can lead to inefficiencies and unequal workload distribution. Paper-based work orders. D. Slow communication and hindered data tracking. Best practices per HVACR Service Management Institute. Technology-enabled dispatch and clear workflows to optimize service operations. Question 9. The fundamental question is, how should Wang approach risk management when planning an HVACR project involving new renewable energy integration in a public building? A. Focus risk assessment solely on equipment failure related to renewable technologies. B. Conduct a comprehensive risk analysis covering technical, financial, regulatory, and safety aspects before project execution. C. Ignore renewable-specific risks and rely on traditional HVAC risk protocols. D. Postpone risk management until after installation to address unforeseen issues reactively. Answer. Correct answer. B. Explanation. Effective risk management is proactive and comprehensive, especially with new technologies involving technical uncertainties, financial investment, regulatory compliance, and safety concerns. Limiting focus to equipment or ignoring renewable-specific risks. C. Is inadequate. Postponing risk management. D. Leads to costly failures and safety hazards. Standards like ISO 31000 Early systematic risk identification and mitigation, crucial in complex HVACR projects involving renewables. Question 10. Taking into account the impact of financial management on HVACR business success, Brown notices project cost overruns consistently tied to inaccurate estimating and bidding. What principle should she apply to improve financial outcomes and ensure competitive yet profitable bids? A. Rely primarily on historical cost data without adjusting for current market changes. B. Integrate detailed load calculations, material costs, labor rates, and contingency allowances into comprehensive estimating software. C. Underbid projects aggressively to win contracts and recover costs through change orders. D. Use fixed markup percentages on rough cost estimates regardless of project complexity. Answer. Correct answer. B. Explanation. Accurate estimating integrates precise load calculations, current material and labor costs, and contingencies to reflect true project scope and risks, improving profitability and bid competitiveness. Solely using historical data ignores market fluctuations. Underbidding. C. Risks financial losses and client dissatisfaction. Fixed markup. D. Oversimplifies and may under or overprice bids. Applying disciplined financial management and estimating aligns with best practices outlined by the Construction Financial Management Association (CFMA). Question 11. By evaluating the implications of psychrometric principles, Thompson is designing a ventilation system for a high-occupancy auditorium where outdoor air is humid and warm. The air must be conditioned to a dry bulb temperature of 75 degrees and relative humidity of 50%. Which of the following steps should Thompson prioritize to ensure effective moisture control and occupant comfort? A. Increase the volume of outdoor air introduced without conditioning to dilute indoor contaminants. B. Incorporate dehumidification using cooling coils to reduce moisture content before reheating is necessary. C. Rely solely on increased air velocity to promote evaporation and reduce humidity. D. Use only high-efficiency particulate air HEPA filters to remove airborne moisture. Answer. Correct answer. B. Explanation. Psychrometric shows that sensible cooling alone will not remove moisture. Latent cooling dehumidification is necessary to reduce absolute humidity. Cooling coils reduce air temperature below its dew point to condense moisture, then reheating can adjust dry bulb temperature without adding humidity. Increasing outdoor air without conditioning A raises latent load. Air velocity C affects evaporation but doesn't reduce indoor humidity effectively. HEPA filters D remove particles, not moisture. ASHRAE standard 62.1 emphasizes proper latent load control for indoor air quality and comfort. Question 12. Taking into account electrical fundamentals, Mr. Williams inspects a three-phase motor in an HVAC system that frequently trips the overload protector despite operating under normal load conditions. Voltage and current readings appear normal. Which underlying electrical issue should be suspected and what should be the corrective action? A. Motor winding insulation failure. Immediately replace the motor. B. Imbalanced voltage supply causing overheating and measure voltage across phases and correct imbalance. C. Mechanical binding in the compressor causing increased torque. Lubricate bearings. D. Faulty overload protector relay. Replace the relay without further diagnostics. Answer. Correct answer. B. Explanation. Voltage imbalance causes motors to draw excessive current and overheat even at normal mechanical load. Measuring phase voltages can confirm imbalance. Motor damage may occur but is a result, not initial cause. Mechanical binding C typically raises current and load, but normal current readings contradict this. Replacing the relay D without diagnosis ignores root cause. National Electrical Code NEC E guidelines recommend addressing voltage imbalance to avoid motor failures and inefficiencies. Question 13. Under the assumption that a large HVACR project requires installation of multiple duct systems, Mr. Kim notices that the ducts have inconsistent air velocity and noise complaints from occupants. What fundamental duct design principle should he reassess to address these issues effectively? A. The duct sizing must balance static pressure and velocity to prevent excessive noise and ensure uniform airflow. B. Smaller ducts at supply points always improve airflow and reduce noise. C. Air velocity has minimal impact on occupant comfort. Focus on temperature control instead. D. Noise is solely caused by HVAC equipment, not duct design. Answer. Correct answer. A. Explanation. Excessive air velocity raises noise through turbulence, and improper duct sizing creates uneven pressure and flow distribution. Balancing static pressure and velocity per SMACNA duct design manual is essential to minimize noise and maintain comfort. Smaller ducts B may increase velocity and noise. Air velocity C significantly affects comfort and noise levels. Noise D can originate from both equipment and ductwork. Correct duct design optimizes airflow and acoustic performance, critical in occupant-focused HVAC systems. Question 14. Given the circumstances of an HVACR preventative maintenance program for a school, Ramirez is reviewing maintenance intervals and procedures. The existing program lacks documentation of core cleaning frequency. What is the potential risk and what best practice should she implement according to industry standards? A. Increased coil fouling reduces heat transfer efficiency. Establish scheduled core cleaning at least semi-annually. B. Core cleaning is unnecessary unless visible dirt is present and no change needed. C. Frequent core cleaning risks damaging coils. Reduce cleaning frequency to once every 2 years. D. Core cleaning should be replaced by filter replacement alone to maintain performance. Answer. Correct answer. A. Explanation. Dirty coils impede heat transfer, causing higher energy use and equipment stress. ASHRAE recommends periodic coil cleaning as part of preventive maintenance, often semi-annually or quarterly depending on conditions. Waiting for visible dirt. B. Allows efficiency loss. Reducing cleaning frequency. C. Risks operational problems. Filter replacement. D. Is complementary but cannot substitute core maintenance. Proper core care improves system reliability and energy efficiency. Question 15. Considering the evidence, Mr. Davis is troubleshooting an HVACR system with erratic thermostat readings and frequent short cycling. The thermostat is relatively new and wiring appears intact. What advanced diagnostic steps should he perform next to isolate the problem? A. Replace the thermostat immediately since it is the most likely fault. B. Test the thermostat sensor with the calibrated device and verify voltage signals to the control board. C. Inspect the refrigerant charge level as the primary cause. D. Adjust the compressor cut and pressure to reduce cycling. Answer. Correct answer. B. Explanation. Accurate diagnostics involve confirming sensor functionality and electrical signals before replacement. Testing with a calibrated device ensures the thermostat accurately senses temperature, refrigerant charge. C. Affects system cycling but not thermostat readings. Adjusting compressor pressure. D. Without identifying cause risks improper operation. Replacing without diagnosis. A. Wastes resources. ASHRAE and HVACR diagnostic guidelines emphasize thorough verification of controls to pinpoint issues. Question 16. For the purpose of selecting new refrigerants, ISCHEN evaluates environmental impact and system compatibility. Which characteristic is the most critical to balance when considering refrigerants under current regulations and operational demands? A. Low global warming potential and high energy efficiency balanced with flammability and toxicity risks. B. Lowest cost regardless of environmental or safety profile. C. High flammability to improve heat transfer characteristics. D. Exclusively zero ozone depletion potential, ignoring other factors. Answer. Correct answer. A. Explanation. Modern refrigerants must meet EPA, SNAP, and Kigali Amendment requirements, balanced reduction and an energy efficiency with acceptable safety profiles, flammability, toxicity. Cost. B is secondary to regulatory compliance and safety. High flammability. C. Limits applicability. Zero op. D is necessary but insufficient alone. At C matter equally. Industry standards from ASHRAE and EPA provide guidelines on safe, environmentally responsible refrigerant selection. Question 17. The growing trend in building automation system BAS integration introduces complex control strategies. ISTA Olson is implementing demand-controlled ventilation vis-a-vis a commercial building. What key sensor data must he prioritize to optimize vis-a-vis operation while ensuring indoor air quality and energy savings? A. Occupancy and co-concentration sensors to modulate ventilation rates based on real-time demand. B. Outdoor air temperature sensors only to control ventilation rates. C. Pressure sensors in ducts alone, without occupant data. D. Static airflow set points fixed regardless of occupancy. Answer. Correct answer. A. Explanation. DCV systems adjust ventilation based on occupancy detected by motion or COS sensors, reducing energy use without compromising air quality. Outdoor temperature. B is important for economizer cycles, but insufficient alone. Pressure sensors. C help airflow measurement but not demand modulation. Fixed airflow. D wastes energy. ASHRAE Standard 62.1 supports DCV to optimize IACN efficiency by responding to occupancy and pollutant levels. Question 18. In response to increased regulatory focus on refrigerant leak detection, ISTA fosters specifying detection methods for a large HVACR system, which approach best aligns with EPA and OSHA standards to minimize environmental impact and maintain safety. A. Implement continuous electronic leak detectors with automatic shutdown capabilities. B. Rely on annual visual inspections for leaks without technological aids. C. Use only handheld detectors during scheduled maintenance. D. Avoid leak detection to reduce operational costs. Answer. Correct answer. A. Explanation. EPA Section 608 and OSHA emphasize leak detection to minimize refrigerant emissions and safety hazards. Continuous electronic detectors provide real-time alerts, enabling immediate response and minimizing environmental damage. Visual inspections, B, and handheld devices, C, are important but less effective alone. Avoiding detection, D, risks regulatory penalties and system hazards. Best practice. Integrate technology with procedural compliance to ensure safety and sustainability. Question 19. In a modern context of energy efficiency and green technologies, Sanchez is tasked with upgrading an existing HVACR system to meet aggressive energy codes. Which retrofit strategy will provide the highest impact while maintaining system reliability? A. Replace existing equipment with high-efficiency models combined with variable frequency drives PFDS for motors. B. Add insulation to ductwork only. T. Increase system runtime to spread load more evenly. D. Use oversized equipment to guarantee cooling capacity. Answer. Correct answer A. Explanation. Upgrading to high-efficiency equipment and VFDS reduces energy use by adjusting motor speeds to actual load demands, aligning with ICANN ASHRAE 90.1 efficiency mandates. Insulation B is beneficial but less impactful alone. Increasing runtime C can raise energy use. Oversizing D causes inefficiencies and short cycling. Integrating advanced equipment and controls yields optimal efficiency and reliability. Question 20. While examining the consequences of improper load calculations, Mr. Martinez observes frequent system failures and occupant discomfort in a multi-zone office building. Which of the following conceptual mistakes is most likely contributing to these issues? A. Using peak design load without accounting for diversity factors and system zoning. B. Calculating loads with software instead of manual methods. C. Overestimating ventilation requirements to improve air quality. D. Applying manual load calculations with accurate data. Answer. Correct answer A. Explanation. Ignoring diversity and system zoning leads to oversized or undersized equipment, causing inefficiency and comfort problems. Peak load assumptions without diversity factor adjustments do not reflect realistic operating conditions. Software B is a tool, and accuracy depends on input. Overestimating ventilation C may increase energy use but not typically cause failures. Manual calculations D are valid if data is accurate. Proper load estimation per account manual J and manual D ensures balanced design and performance. Question 21. Within the framework of load calculations, Mr. Singh is designing heating and cooling loads for a 6-unit multifamily complex with varying occupancy schedules and internal heat gains from appliances. He must select peak design loads to size the central plan without oversizing. Which approach best balances accuracy and efficiency? A. Use the highest individual unit peak load multiplied by 6 to determine total plant capacity. B. Sum the calculated peak loads of all units with a 100% diversity factor to ensure full simultaneous peak capacity. C. Apply appropriate diversity factors per account manual J to individual unit loads before summing, then add common area loads. D. Size the plant for average daily loads only, ignoring demand. Answer. Correct answer C. Explanation. Applying diversity factors recognizes that not all units peak simultaneously, preventing plant oversizing and high capital operating costs. Account manual J outlines residential load calcs diversity adjustments, summing individual peaks without diversity. A. B. Leads to oversizing. Sizing for average loads. D. Risks undercapacity during peak. Proper diversity use ensures reliability and occupant comfort while controlling energy use and capital expenditure. Question 22. In comparison with traditional water systems, selecting pipe diameters and pump capacities for a new chilled water loop requires understanding of flow, head loss, and pump curves. Which of the following design principles should Jackson apply to optimize hydraulic performance? They oversize pipes to reduce head loss without verifying pump efficiency at low flows. B. Balance pipe diameter, length, and pump selection so the system design point lies near the pump's best efficiency point. C. Select the smallest possible pipe diameter to minimize material cost regardless of velocity. D. Choose pump with maximum head capability to cover all future expansion scenarios. Answer. Correct answer B. Explanation. Designing near a pump's BEP maximizes efficiency and longevity. Proper pipe sizing mitigates excessive velocities, noise, erosion, and head loss. Oversizing pipes A may reduce head loss but can increase material costs and slow flow. Undersizing C raises velocity and friction losses. Overspecified pump head D can cause unnecessary energy use and control issues. ASHRAE and Hydraulic Institute guidelines emphasize matching system curve and pump performance. Question 23. Considering the evidence from inventory and supply chain management, is it Chen oversees spare parts for a nationwide HVACR service operation? High-value components are often backordered, causing downtime. Which strategy should she implement to optimize inventory while minimizing carrying costs? A. Maintain a uniform safety stock level for all parts irrespective of criticality or lead time. B. Implement ABC analysis to classify parts by criticality and consumption. Adjusting reorder points and economic order quantities accordingly. C. Rely solely on vendor-managed inventory to handle all stock replenishment. D. Eliminate slow-moving parts to reduce inventory value regardless of operational impact. Answer. Correct answer. D. Explanation. ABC analysis. B is best practice, where items critical high use have higher safety stock and shorter reorder cycles. C items low use have minimal stock. Uniform stock. A wastes capital. A sole vendor managed inventory. C may improve turnover but reduces control, eliminating critical slow movers. D risks downtime. Implementing ABC per score model and say guidelines balances service levels and carrying costs. Question 24. The fundamental question is, how can a project manager ensure timely completion of a complex HVAC retrofit with overlapping mechanical, electrical, and control trades? A. Develop a detailed work breakdown structure. B. Use critical path methods, CPM, scheduling, and hold regular cross-disciplinary coordination meetings. B. Assign all tasks to a single general contractor to simplify oversight. C. Schedule trades sequentially without overlap to avoid coordination issues. D. Rely on ad hoc adjustments in the field without formal scheduling. Answer. Correct answer. Explanation. WEPM schedule identify dependencies and critical tasks, enabling proactive management. Regular coordination aligns trades, preventing delays. Single contractor. B. Centralized but doesn't replace structured planning. Sequential scheduling. C. Prolongs project duration. Ad hoc field adjustments. D. Risk scope creep and conflicts. PMIS PMBOK and SIPMI standards recommend formal scheduling and communication for complex projects. Question 25. Several experts suggest that effective HVACR sales strategies hinge on understanding client needs and value proposition. Which approach best aligns with consultative selling in the HVACR industry? A. Highlight lowest upfront equipment cost without discussing lifecycle performance. B. Conduct a needs analysis, present tailored energy saving solutions, and demonstrate ROI using case studies. C. Focus on high margin add-ons regardless of client relevance. D. Use aggressive discounting to close deals quickly. Answer. Correct answer. C. Explanation. Consultative selling involves in-depth needs assessment, solution customization, and ROI demonstration. Emphasizing lifecycle costs and benefits builds trust and long-term relationships. Lowest cost focus. A. Or high margin push. C. Ignores clients' strategic goals. Discounting. D. Erodes margins and perceived value. Sales best practices per spin selling and HVACR sales guide stress value-based proposals and data-driven ROI analysis. Question 26. In an effort to expand service offerings, ISTA Rivera reviews a service contract template for potential liability. Which contractual clause is most critical to protect the HVACR firm from unforeseen site conditions and cost overruns? A. A fixed price clause without adjustment mechanisms. B. A force majeure clause and clearly defined scope change provisions with unit pricing and approval process. C. A broad warranty guaranteeing free repairs for the life of the system. D. An indemnification clause solely favoring the client. Answer. Correct answer. B. Explanation. Force majeure addresses events beyond control. The scope change clauses with unit pricing and approval mitigate cost overruns due to unforeseen conditions. Fixed price contracts, they expose contractor to risk. Lifetime free warranty. C. May be financially unsustainable. One-sided indemnity. D. Increases liability. A balanced contract per IAN Act calls standard forms ensures clear scope, change and risk allocation. Question 27. The growing trend in renewable energy systems includes solar-assisted heat pumps, which key performance metric must engineers evaluate to determine viability for a retrofit project? A. Photovoltaic panel color to match building aesthetics. B. Coefficient of performance, COP of the heat pump integrated with solar thermal preheating across seasonal conditions. C. Manufacturer's name recognition irrespective of performance data. D. Inverter capacity separate from thermal system integration. Answer. Correct answer. D. Explanation. The COP under real-world conditions combining solar thermal preheat and heat pump workload is essential for energy savings estimation. Aesthetic color A is cosmetic. Brand alone C doesn't guarantee performance. Inverter capacity D influences electrical integration but must align with thermal COP analysis. Engineers should model seasonal COP per NREL guidelines for system viability. Question 20. In what ways can an HVACR engineer improve indoor air quality in a densely occupied classroom building while balancing energy use? A. Increase outdoor air intake per ASHRAE 62.1 and add demand-controlled ventilation based on COES sensors. B. Rely solely on higher filtration MERV ratings without adjusting ventilation rates. C. Keep windows closed at all times to maintain HVAC control. D. Use ultraviolet germicidal irradiation of B without adequate airflow distribution. Answer. Correct answer A. Explanation. Combining increased outdoor air per ASHRAE 62.1 with DCV optimizes ventilation and energy use by responding to occupancy. High MERV filters. B. Improve particulate removal but can increase pressure drop and energy. Closed windows. C. Limit natural ventilation potential. Of the D aids pathogen control but is ineffective without proper airflow. Balanced IX strategies integrate ventilation, filtration, and control technologies. Question 29. Through careful analysis of operational data, Evans identifies that a fleet of rooftop units have varying runtimes and energy consumption despite similar loads. Which data analytics approach should she apply to pinpoint inefficiencies? A. Compute mean runtimes only and adjust maintenance schedules accordingly. B. Perform regression analysis correlating runtime and energy use with external variables, outdoor temperature, load profiles, to identify outliers. C. Rely on technician observations without quantitative analysis. D. Compare only nameplate capacities to runtime. Answer. Correct answer. B. Explanation. Regression analysis uncovers statistical relationships between energy use, runtime, and influencing factors, highlighting units operating inefficiently. Mean runtime alone A. Overlooks contextual variations. Technician anecdotes C. Lack data rigor. Nameplate capacity versus runtime D. Doesn't account for operational conditions. ASHRAE and ISO 50001 recommend data-driven energy audits using analytics to target performance issues. Question 30. A key distinction between quality control and quality assurance emerges in HVACR commissioning. Which action exemplifies quality control during system startup? A. Developing commissioning checklists and protocols before installation begins. B. Conducting functional performance tests. Verifying sensor accuracy, airflow, and set points, and documenting failures for immediate correction. C. Training staff on quality management principles during project planning. D. Auditing the overall commissioning program's effectiveness post-completion. Answer. Correct answer. B. Explanation. Quality control involves real-time testing and inspection. Functional tests during startup ensure equipment meets performance criteria and allow corrective action. Pre-installation protocol development A is quality assurance. Staff training C also falls under CAR. Post-completion audits D. Assess CAR program outcomes. ASHRAE Guideline 0 distinguishes UC tasks, testing, inspections from CAR processes, planning, auditing.